If I asked you what the biggest threat to the global internet is, you'd probably guess the sophisticated hack, right? Or maybe some giant ship severing an undersea cable. But actually, it's a lot stranger than that. It is a microscopic sliver of time. In this explainer, we're diving into this crazy, high stakes conflict between the fundamental laws of planetary physics and the super rigid code that runs our entire digital world.
Look at this timestamp, 23 hours, 59 minutes, and 60 seconds. Your brain is probably already flagging it as a typo. I mean, there's no 60th second on a standard digital clock. It just rolls right over to midnight. But here's the thing. This impossible timestamp, it's totally real. And when it hits, it triggers a literal catastrophic ripple effect through the foundational software of the internet. So to understand exactly why a single tiny second can bring down massive server farms, we first got to understand why this bizarre timestamp even exists in the first place. So let's get into section 1, the 1-second panic, and this whole system crashing glitch.
Which brings us to section 2. Earth is actually a terrible clock, all thanks to tidal friction.
Okay, so a strict 24-hour day, it's really just a mathematical illusion. We're all taught that the Earth spins like this perfect top. But nature is messy, right? Our planet is constantly battling something called tidal friction. Picture this. As the moon orbits, its immense gravity physically tugs at our oceans. This creates a massive shifting of water that basically acts like a giant brake pedal dragging against the ocean floor. That friction is literally stealing Earth's rotational energy. Because of it, our days are actually growing a tiny fraction of a millisecond longer over the centuries.
And this right here creates our core dilemma. Think about it. On one side, you have human engineering. We've built these ultra-precise atomic clocks that measure time using the vibration of atoms. They literally never lose a single second, even over millions of years. But on the other side, we've got our messy, constantly slowing planet. If we just completely ignore this mismatch, well, eventually, noon on our clocks would happen in the middle of the pitch-black night. Obviously, we couldn't let that happen, so humanity had to step in.
So the fix was introduced by scientists back in 1972, and they called it the leap second. The concept is pretty simple, but honestly, it's profound. Whenever the Earth falls a little too far behind our atomic clocks, the world's timekeepers literally agreed to hit pause on global time for exactly 1 second, just to let the planet catch up. They're forcing our clocks back into alignment with the sun's actual position in the sky. So instead of going from 23:59:59 straight to midnight, the clock ticks to 23:59:60. It takes a deep breath, waits 1 extra second, and then boom, midnight. Problem solved, right? We keep time and the sun in perfect harmony. Well, yeah, it was a fantastic solution for the 1970s, but nobody in 1972 could have possibly predicted the internet. Moving on to section 3. The 23:59:60 system crash. This is what happens when time repeats. Think about our modern operating systems for a second. Specifically, let's talk about Linux, which is essentially the backbone for the vast majority of global web servers. Now, Linux relies on a very strict, completely linear progression of time. Time moves forward, always. But when a leap second drops, the system sees that 59th second and is suddenly told to just wait. To a Linux machine, a repeating second means time is either moving backward or completely standing still. That foundational logic totally shatters, and the software just panics. This confusion throws the software's internal task manager into an infinite loop. The CPU, the literal brain of the server, spikes instantly to 100% capacity trying to resolve this mathematical impossibility. It rapidly overheats, it freezes up, and it completely crashes. Just imagine a perfectly healthy server brought to its absolute knees simply because the Earth is spinning a tiny bit too slowly and the clock happened to strike 60.
Crazy, right?
And guys, this isn't just some theoretical lab glitch. The stakes here are incredibly high. That single extra second has caused massive, real-world casualties on platforms that millions of us use literally every single day. I mean, in the past, when a leap second hit, it knocked Reddit completely offline, gone. It's caused airline booking systems to just freeze up entirely, leaving passengers stranded, unable to check in or buy tickets. It has even glitched out these incredibly sensitive financial trading platforms where mere milliseconds dictate millions of dollars in trades. You simply cannot have the backbone of global commerce crashing because of a planetary speed bump. Engineers knew they desperately needed a fix, but they obviously couldn't control the Earth's rotation, and they definitely couldn't just rewrite all of Linux overnight.
That leads us right into Section 4, the time-smearing workaround, and how we go about absorbing the delay.
So, tech giants like Google and Amazon realized they essentially had to trick their own systems. They engineered this brilliant, almost stealthy solution called time smearing. Here's how it works. Instead of slamming their servers with that sudden, terrifying 60th second, they chop that 1 second into minuscule fractions and then spread it out or smear it over an entire 24-hour period. By running their server clocks a tiny, tiny fraction of a percent slower than real time for an entire day leading up to the leap second, the servers quietly just absorb that delay. So by the time midnight finally rolls around, the digital clock simply flows gracefully into the next day without ever having to process an impossible timestamp. It is an incredibly clever Band-Aid that completely prevents a total internet meltdown. But make no mistake, a Band-Aid is exactly what it is.
Now for Section 5, abandoning the leap second, the final resolution.
This whole saga literally spans decades. We've gone from the naive optimism of 1972 all the way through our modern era of these complex time-smearing workarounds, just trying to hold the internet together. But honestly, the technical chaos has just become way too severe. Because of the ongoing danger to our global networks, scientists and timekeepers recently held a vote and made a truly monumental decision. By 2035, humanity will officially abandon the leap second. We are actively choosing to let our atomic clocks slowly drift away from the imperfect rotation of our planet, rather than forcing our fragile software to constantly play this game of catch-up with the changing physics of a slowing Earth.
And by choosing digital stability, we are fundamentally severing a bond between human timekeeping and the actual physical rhythm of our solar system. I mean, for thousands of years, time was dictated by the sun and the stars. But soon, it'll be dictated purely by the unbreakable, unyielding vibration of the atom. We fixed the internet, sure, but at the cost of decoupling ourselves from the cosmos. So it really leaves us with this one thought. Are we truly ready to let our clocks drift away from the sun forever?